So those are the kind of welds that we can achieve, right? Precise and of good quality with the help of this TIG welding, right? Tungsten and gas welding. As for the disadvantages, you see you have lower filler metal deposition rates. So this is the tungsten electrode. This is the filler metal that we are providing. So it supplies lower filler metal, right? The deposition rate is lower because, well, if you are trying to have more control over the material that is added, then you have to compromise on the deposition rate, right? But if you're looking for more deposition rate, then this is not the correct process because the deposition rate is very low. Nevertheless, it is able to achieve finer quality welds, right? Other things is other disadvantages are slower travel speeds than other processes, right? Travel speeds that the weld torch is able to move is slower. The equipment costs tend to be higher than other processes, right? Because it is a precise machine, you have to require, it requires a lot of costs. Then good high-end coordination is a required skill, right? So as you can see in that figure there, that a lot of precision is required, a lot of skill from the welder is required to be able to achieve good quality welds, and so that the weld doesn't spatter or there's no porosity or overheating of the weld metal or filler metal, etc. So a lot of care is to be taken, and there has to be good hand and eye coordination, right? So that you can achieve that good weld. Brighter UV rays than other processes, right? That is also another disadvantage. So as for the key points, it is an exciting skill that proves itself useful in countless applications, right? As I said, aerospace industries relies much on TIG welding because of the accuracy and the precision, right? And what is the difference between accuracy and precision? Okay, you might not have studied metrology, right? We have this in our syllabus, mechanical, but nevertheless, the key difference is in accuracy, you're trying to achieve a certain value. Let's say maybe, if you check your weight, right, on a weighing machine, and you found that the weight is maybe 55 kg, okay, and that's if your actual weight is 55, right, and the weighing machine shows 55, you can say the machine is accurate. Accurate reading is what we can call. Now, precision is ability to achieve the same value, okay, at multiple measurements, right? So if I'm measuring it right now, I'm measuring it 2 hours later, 2 days later, 2 weeks later, 2 years later, okay, it should be able to give me the same reading. Repeatability we can call as precision, right? We are able to repeat the result, and that is same. And it can be wrong, right? It is very much possible that it is wrong. Every time the machine can give wrong reading, but still be precise, right? It's not accurate, but it's precise because it's giving the same reading, although it is wrong. I hope I'm clear with that point. So that's accuracy and precision. Now, because it builds more metal and metal alloys in any other process, TIG welding should be regarded as an important tool that experiences the teacher, right? So the skill of the operator is much required, and as we have discussed, more metal and metal alloys can be welded with the help of this welding. Welding parameters and tungsten electrode selection tables are recommended values. They should be used as a guideline. So the parameters that you're going to choose, the tungsten electrode selection table, what type of tungsten electrode to choose. These are all, they have prepared some guidelines, so those can be used for proper selection of these parameters and values. You see, this is the video. Shall we have the video?
Tired of cold
welding. The TIG welding consists of power source, coolant system, gas valve, regulator flow meter, shielding gas cylinder, remote control, gas in, gas out, work clamp, coolant in, coolant out, workpiece, torch,
Right? Pretty much the same kind of equipment that we had earlier for arc welding or any other gas welding also. The key difference is you have one cylinder, that is the shielding cylinder, shielding gas cylinder. The power source is there, yes. There's an arc generated, yes. There's also this coolant, right? To be able to cool down the temperature, to be able to achieve that temperature. You have control over the temperature at the weld area or the electrode, etc. You also have the coolant system. Right? So let us have a look at the weld.
filler rod, shielding gas nozzle, non-consumable tungsten electrode. In this process, an electric arc is produced between a non-consumable tungsten electrode and the workpiece. By supplying the electric power and the inert gas from the cylinder passes through the nozzle of the welding head around the electrode. The inert gas surrounds the arc and protects the weld from atmospheric effects, and hence defect-free joints are made. It is also used for combining of dissimilar metals, hard facing, and the surface of metals.
Right? Any doubts on that video? Right? Well, that is about TIG welding. Okay, tungsten inert gas welding. Now there is another category called MIG welding, right? This is also very similar to the previous one. TIG and MIG is the short form, right? Tungsten inert gas welding for TIG, metal inert gas welding for MIG. There is also another name for MIG welding, gas metal arc welding, right? Just as you had the other name for TIG welding as gas tungsten arc welding, you have here gas metal arc welding. We'll see why it is called gas metal arc welding. Just to define it comprehensively, you have the definition. It is a process where a continuously fed metal, right, that is electrode, which is basically a wire, contacts the base metal, produces arc, and consequently heat is generated, and the weld area is shielded by an inert gas. Right, that's what's happening. That you have when that electrode it contacts the base metal, it produces the arc, and therefore because of the arc heat is generated, and the weld area is shielded by an inert gas. And that is what is important here also. In TIG and MIG, we are using an inert gas, as the name suggests, metal inert gas welding, MIG welding, right? So inert gas supply is also there. You see here, you have the regulator, which is carrying the shielding gas. I'm sorry, you have the cylinder which is carrying the shielding gas, right? That is what is responsible for supplying the shielding gas to the weld area. Now there is another thing called wire spool, right? This is what will supply the filler metal. Okay, so the filler metal is having a proper setup. We have wire feed control, right? How much of the wire is coming out, the speed of it, etc. So that wire spool will be continuously feeding the wire, right, to the torch. The torch is also receiving the shielding gas, and therefore it welds the metals. Okay, a closer look up would be here. You see, this is your electrode, and the nozzle will be the shielding gas, right, all around the electrode and the area which is to be welded, and also the area that has been welded. Okay, so you have the weld pool there because of melting of that base metal, and the bead that was formed is shown in this color. So I hope it is clear. You will see the components of gas metal arc welding. You have the DC or direct current power supply, and that is very much essential. AC is not used when it comes to the stick and MIG welding. So direct current power supply is being used. Electrode or wire feed controller, as I was talking about, you have the setup for supplying the wire feed. That basically the wire drive roller assembly, right, which will carry that wire. Shielding gas source, cylinder basically, and regulator along with it. Manually held gun and ground clamps. So that gun is basically their torch. Okay, it's also called gun sometimes. And then you have the ground clamps and wire wheel. So you see the principles of gas metal arc welding. You have the as we have discussed, what is GMAW, or basically TIG welding. It is gas metal arc welding. That's the full form of GMAW. Commonly referred to as MIG, right? And during the gas metal arc welding, a solid metal wire is fed through a welding gun, right, and becomes a filler material. So that is to be supplied, right, through a mechanism. Instead of flux, shielding gas is used here, which is used to take the molten puddle from the atmosphere, which results in a weld without slag, right, a good quality weld. It's the most commonly used arc welding process in the United States. Okay, MIG and TIG are generally used for precise works. Now, you see the circuit. Three things happen when the gas metal arc welding gun trigger is pulled. So the trigger you have there, right, which is to be used by the welder when he is welding. So that trigger, what happens when the trigger is pulled is what is explained here. It's that the wire electrode begins to feed, right, because you have to supply the wire, as I was talking about metal wire. So that if that is to be supplied, you have to have a feeder kind of system. The wire electrode begins to feed, and the other thing is the circuit becomes electrically hot, right, once that gun trigger is pulled. Okay. Current flows from the power source through the gun cable, right? and then to the gun, to the contact tip of the wire and across the arc, right? Once it generates the arc, you have the flow of, I mean, a resistance is generated and that is responsible for generation of the heat. On the other side of the arc, current flows through the base metal, right? To the work cable and back to the power source, right? So how that circuit is completed is what is explained here. Shielding gas flows through the gun and out the nozzle, right? It reaches that weld area through the gun and then it is released to the atmosphere. A closer look at the gas metal arc welding process as we are traveling from here to there, right? Just as you had in TIG welding, same process we have for MIG welding. The point here is the electrode which is carrying that wire, right, is a consumable one. The electrode is consumable here in this case, whereas it was non-consumable in TIG weld. That is what is the basic difference, right? The R principle is same, the setup is same, the wire feed assembly is to be given to supply that wire as I was talking about, because that will melt and form this weld area, right? So the electrode is a metal wire. It is fed through the gun by the wire feeder, as I was talking about. You have this feeder system, and it is measured by its diameter, right? These electrodes are commonly packaged on spools, reels, and coils, ranging from 1 pound to 1,000 pounds, right? So that arc that is generated, it occurs in the gas-filled space between the electrode wire and the workpiece. You can see here a very clear view of how that arc is generated between the electrode and the base metal. So that's how it looks like. Able to achieve that focused arc is what is the advantage of MIG and TIG welding, right? And these can generate range temperatures of 10,000 degrees Fahrenheit. It's quite a lot. Right? Other thing is weld puddle, right? As a wire electrode and workpiece heat up and melt, they form a pool of molten metal material called a weld puddle, right? Because they are melting, right? The workpiece heat up and then melt. This is what the welder watches and manipulates while welding, right? And we need to check whether that molten material is not spattering because of more heat, or there is no porosity because of less heat. We have to ensure that it heats up and melts appropriately, right? So this is an excerpt from, with the details, right? How much volts and how much percentage of shielding gas was used, etc. So shielding, as we have discussed, as the name suggests, it shields, protects the weld puddle, right, from contamination or oxidation. It is usually carbon dioxide, argon, or a mixture of both, right? The gauges in the regulator show gas flow rate and bottle pressure, right? That is what they are responsible for. So we can check the gases, the gas present inside is sufficient for a certain weld to be taking place, and the flow rate that is happening, right? How much amount of gas is being released. Shielding gas, as we have discussed, it shields, right? It's an inert gas, doesn't allow much reaction to take place. Molten metal, it prevents you from contamination, right? From oxygen, nitrogen, and water within the atmosphere. So atmospheric gases doesn't react with the inert gas, and therefore the weld area is safe. Insufficient gas flow will not displace the atmospheric gases and resulting in porosity, right? If there's not much gas flow, then it will not displace the atmospheric gases which are surrounding the weld area. So that results in porosity because of that gases remaining inside the weld, right? So that is another disadvantage if there is not much gas flow, right? Flow is measured in CFH, cubic feet per hour. So when excessive shielding or gas coverage is there, it will cause porosity, as we discussed. And the turbulence that is caused because of more gas, right? It flows in, right? The gas flows in because of excessive, because of the excessive nature. as we were talking about. If you're supplying excessively, then there will be turbulence. It will not be stabilized, right? So because of this turbulence, it will create a negative pressure gradient, right? The pressure here will be less, and therefore the atmospheric gases are bound to come to this vacuum that is created because of the turbulence. I hope I'm making it clear, that point. So that is also another disadvantage of having more shielding gas. The thing is, it will reduce weld pool temperature, causing decreased penetration, right? More gases leads to lesser heat generated, and therefore decreased penetration because of not achieving that threshold heat that was required for certain penetration. So the last point is the weld metal, right? Lays a bead of molten metal quickly solidified in the weld. You can see the quality of the weld, right? It's an aluminum weld done with this MIG welding process, gas metal arc welding. It is slag free, right? No slag, etc. Because of that inert gas, presence of inert gas. I hope we should see the advantages and disadvantages in the next class, hopefully. It's already time. Okay. Let me take the attendance. Okay, then. If you have got no doubts, then we can end the class. Okay.